I would like to request all attendees to rename your name to the name by which you wish to be identified in this session. A question and answer session will be held at the end of this session, and all attendees are welcome and are encouraged to ask any and all questions you may have. It is preferred if you can type the questions in the chat box. However, if you are traveling and if you're joining from a mobile device, we understand that typing might be a hassle. So in such a case, you can raise your hand and I'll call upon you to ask your question. And except in such an event, please be kind enough to keep your microphones muted at all other times. Thank you. Electric vehicles is a very current topic these days, and we all agree upon the fact that they are going to be the future. As fossil fuels become depleted, humanity needs to find a new way to power our transportation needs. And creating this transition from fossil fuel-driven vehicles into electric vehicles is something that requires a great deal of mechanical engineering and a considerable involvement of mechanical engineers. Today, this webinar is delivered by one such engineer who is striving to bring this change through mechanical engineering. Mr. Mahesh Shinde is a chartered engineer with nearly 40 years of experience in the automotive field. He's the founder-owner of MS Sage Engineering Consultancy, which is an individual consultancy service in automotive engineering and manufacturing sector. He was the former senior GM and head vehicle attributes and technical service in the Engineering Research Center of Tata Motors. He obtained a diploma in mechanical engineering from BET Mumbai. He has a degree in mechanical engineering from Pune University, a diploma in business management and computers from Pune University, and a master's in management science. For his contributions towards mechanical engineering, he was awarded the prestigious fellowship of the Institution of Mechanical Engineers. I would now like to invite Mr. Mahesh Shinde to start the webinar and enlighten us all upon the basics and architecture of electric vehicles. Over to you, sir. I'm sorry, sir, I think you're muted.
Is it okay now?
Yes, it's perfect.
Okay. So thank you for nice introduction. I feel elated a little bit, but anyway, thank you. I'll start sharing my presentation. My request to you, Lakinder, will be at any point of time if I get cut off or if the voice is not coming, please let me know so that we can take off from there once again. Is my presentation now visible?
Yes, sir. You're clear and visible.
Okay, so we can start. So good evening, everyone. I know this is a heart-touching topic, as Lakin said that we are driving towards electrification of vehicle, and this is one of the area where we have been working. But let me, tell you something about this. That typically for Southeast Asia and Southwest Asia, the electric vehicles are growing fast. In Europe, it is in the decline for a couple of reasons. Just to give you an idea that probably the pollution that the lithium batteries are causing, then the upper hand of Chinese people because they own about 74% of the lithium mines. So it creates some monopoly kind of thing. And most importantly, somehow the safety of the vehicle is still at a stake, especially when it is very cold in European or North American countries. There is a possibility of having a thermal runaway or thermal injury. So this is a basic thing that probably we see that there is a decline of electric vehicles. Not much, but yes, there is a decline. At the same time, in our part of the world, it is growing fast. And I'm happy to share that Tata Motors is currently holding about 72% of passenger car electric vehicles in India over its competitors. So that's one of the things that I would like to tell as a preamble on the subject. Now, this electrification of vehicles, what exactly it is, we are going to see what it is to make an electric vehicle, what are the different components, elements, and structure of that. And then you will also see some of the basic things as what components can be thought of and what will be the configuration of or the architecture of the vehicle. However, when we talk about new vehicle development, especially in EV domain, there are few principles that we take into consideration. Almost every OEM, not only Tata Motors, but every OEM takes into consideration worldwide, and these are why we want to have this electric vehicle. First, everyone is aware of the green future or the green environment and are going in for better and better world, and that's why the electric vehicle do not produce the emissions such as the carbon monoxide or carbon dioxide in case of NOx in case of diesel engines, and then the hydrocarbons again back into the gasoline engine. So this is one aspect. Second is, irrespective of what gases we are going to produce, there is also carbon buildup. The greenhouse gases and the pure carbon particles that we are going to get into the environment is also detrimental from the respiration point of view, as well as the depletion of oxygen, etc. So low carbon development is another principle that we should look for when we develop a vehicle, and that to move towards the electric vehicle. Then in most of the countries, the transport is much more, and usually the transport uses the diesel fuel or biodiesel or ethanol or something prevailing over the gasoline. So we need to know what it takes to operate into a ecosystem of transport system, which is logistic, the cargo moving and other thing, because the traffic density makes it much more pollutant. Had it been a low carbon or low traffic density, we will be moving much more faster. So we have to make sure that we have this transport ecology. Let's say we call it as an intelligent transport system brought into the environment so that we have much more better environment, and people are becoming aware of it. Since transport is the major portion which pollutes in terms of carbon dioxide, and NOx, we want to decarbonize this transport sector so that major chunk of the pollution goes down. And the last principle is, it's just not emission, it's just not pollution. When I talk about emission or pollution, it's not only the gases, it's also sound, because you know very well that there are certain restrictions on the sound pollution of the vehicle, and it has to pass certain norms. But more importantly, let us say almost every country has got a life defined for the vehicle. Let's say, for example, in India, we have to scrap the vehicle after 15 years of service. That too, last 5 years, you have to reapply for the roadworthiness of the vehicle by paying certain amount and making sure that it is not producing much more gases. So sustainability is much more in focus, wherein these vehicles have to be scrapped in 15 years max, let us say. If that is the case, what happens with the scrapped vehicle, its parts and other things? Usually, so far, it used to go to a landfill as a solid waste. But nowadays, people are thinking of why not use RRR principle, that is reuse, reduce, and recycle. So if we can reuse or reduce or recycle the material, that's better. So OEMs are getting into materials which can be reused or reduced or recycled. And then that means that that much quantity of the solid waste will not get into the landfill. Otherwise, we do have a problem of a landfill and have heaps of parts which are lying in that ground and slowly, making a mountain out of it. So the focus will be on the sustainability ways in terms of RRR. For example, I'll tell you that about 2 or 3 years back, we started an initiative to collect all the front and rear fenders of the vehicle which have met with an accident. Obviously, it's not of use. And then we shredded it, make it a granule form, reconfigure the combination so that we can remold that plastic back into the fender without losing its properties or desired mechanical strength. So this is one of the way to recycle. The reduction of plastic can be done by using a banana fiber to make the fenders. Or you might have heard or seen or read that the GM is using crushed coffee beans, which are otherwise used for the making coffee. These beans, the crushed beans, are being used now the internal trims of the vehicle. Internal trims meaning internal parts of the vehicle, which fits on the A pillar, B pillar, or C pillar. So this is how the development principles govern the development of the vehicle in which form it should take. So now, once we have these principles in place, then we can first find out what is, for any vehicle, what is the energy source. Conventional is internal combustion engine. That is, as you can see, we can have fossil fuels, we can have biodiesel, we can have gases, that is CNG, LNG, or PNG, and then we can have the different blends. Now, why these blends? One is that for a country like India or Brazil, or for that matter, probably Sri Lanka also, sugarcane is not much, right? So the ethanol production is much more. Now, if you blend 5%, 10%, 20% ethanol into fuel, it enhances its value yet reduces the emissions. Now, today, if you see, we are somewhere around 7 to 8% of blending. Only problem is that so much ethanol is not available, and we need to bring more land onto sugarcane crop to produce required ethanol. Second problem in blending is that there are very few blenders who can do it to mix it with the gasoline. There was an attempt somewhere. I remember that that time I was working with two-wheeler company, and we experimented on methanol also. But methanol has a bad effect on the rubber part, so this idea was dropped. And the government policy is governed or decided by the OEMs which are on board of that particular commission, and then we decide. So ethanol was taken up, and today we are planning to have 20% of ethanol blending in gasoline. Just as an information, Brazil is conventionally up to 75% of ethanol blending as well, and they can very well run the vehicle with ethanol. So this is how the internal combustion development is going on. Obviously, there are certain attempts of making the engine operating on air or water, and with a limited success, with cost impact, with technical maturity. There are certain issues which I think it will not be much more commercially viable within next 8 to 10 years also. But that has driven the OEM industry to think of other areas. Typically, if you see between internal combustion engine and electric motors, there is also a development which is going on for hybrid. So it's a combination of ICE, that is internal combustion engine, and electric motor. We will come to that later, but just to give you a match on what is happening. Now, when we talk about electric motors, there are different types of electric motors. One, direct current DC motors with brush, DC motors without brush, PMSM, that means permanent magnet synchronous motors, and then the switch reluctance motors, SRM. Sorry? Should I continue?
Mr. Kaushalya, could you please?
Yeah, please
mute your
continue.
mic,
There's the
please?
noise.
No, that's okay. I thought that somebody wanted to ask something. Okay. Now, to power these electric motors, we have to have an energy source in terms of battery. Now, erstwhile in 1960s in America, still the lead acid batteries were used to power the electric motor. But then because of the longevity, the range, and the capacity, and the motor power output has made it obsolete to use lead acid battery for the electric motors. Then came nickel metal hydride, but again it has got a capacity on the storage. Then went to lithium ion. Now, as I said, China owns 74% of the lithium mines all over the world, and they are in a monopolistic situation. So people are going in for different combinations within the lithium ion, whether LFP or MNC, and to find out the alternate to lithium ion. Now people are working on sodium ion and aluminum ion batteries. Now these are the batteries which will produce less pollution. When we talk about pollution coming out of battery, remember one thing, that after usage of the battery, let's say on an average 5 to 8 years of life, you need to discard the battery, and usually these are buried. When they are buried underground, it contaminates the water body below the ground, and the water becomes a bit poisonous. So obviously people are thinking of getting into better and better materials, and have arrived to sodium and aluminum ion batteries. Again, there is a research going on, and I think within next 2 3 years we should see a major breakthrough, because today when we want to use sodium ion or aluminum, it's very costly and still in the nascent stage. But I'm sure that within next 2 3 years, not only the technical prowess will improve, but also the cost will go down substantially. So this is how the electric motor will work. An electric vehicle will be based on these kind of batteries. There is also a hydrogen fueled vehicle. Now, this hydrogen fuel vehicle can be a fully hydrogen fueled or a mixed kind of cycle. That means hydrogen is injected into ICE, that is internal combustion engine, along with the fuel, fossil fuel. Now, why this? Probably you can get better and better efficiency. And since there is a hydrogen, the emission is brought down in the form of the emission will be water vapor. So there is a trend going towards hydrogen fuel vehicle, wherein the hydrogen either will have a tank on board or will have a onboard plant which generates the hydrogen out of mixing water with the oxides of different materials like aluminum or sodium. So this is one of the area where the energy source will be there. And then it becomes fuel cell. Now fuel cells essentially will be clubbed with the electric vehicles. The fuel cell actually operates on generation of the water, the fuel, the electric charge through photosynthesis or disintegration, or it can use a non-conventional energy or renewable energy like solar. There are various types of fuel cells based on its structure, what is the cell type, whether it is unitized or it's separate cells, and then whether the separate cells are stacked together like in electric battery pack. You have small cells, same way a fuel cell can also be thought of. So these are the basic energy source, and we are focusing on electric motors for our knowledge sharing. Now, electric vehicles, certain points are there. What basic problem is that weight of the vehicle. Because the battery is heavy, the curb weight of the vehicle is very high as compared to conventional vehicle. And then the power required for, motor and the capacity of the motor is high. And then if you have, then again it increases the weight. So it's kind of a vicious circle, and we have to find out the efficiency out of it. And definitely, since the infrastructure is not so vividly available, at least in India, we need to have more and more range within one charge. And the charging has to be more or less in shorter duration. The range, definitely when someone wants to go from point A to point B, that person should have enough charging infrastructure during the travel. Otherwise, it doesn't become a viable solution, isn't it? The third point in electric vehicle design has to be thought of is what is the temperature that you are reaching. You might have heard or seen or read in newspaper the thermal incidences. Typically in America, because of the very cold temperatures, the battery just froze and did not give up. So people started using the auxiliary engine, and then you had a temperature issue of that. So these incidences necessitated the EV design to have a fire suppression system, meaning what? If the temperature rises beyond certain thing and the wires become hot, then there is a pipe running under the bonnet or in engine bay, which will spray the powder or the chemical, which foam, which will suppress the fire automatically. So this is the major area where people have started thinking of having a fire suppression system. Battery raw material, as I said, we talked about. Then the technology. We have to have indigenous technology. Today, what happens is that almost the entire world is importing motors, controllers, and batteries from China for two reasons. One, as I said, monopolistic, and second is that they have a huge production at a very cheaper cost. So obviously, people are finding it much more attractive, and that's why it is becoming more popular. But how much we rely on them, that's why we have to produce our own indigenous way of creating or manufacturing the batteries and the battery pack. One such attempt is being, progressed in Tata Motors. We soon will come out with our own battery pack and the motors. Controllers will be still imported from mostly from the Europe, but that's the way it is. Now, again, as I say, that certain things are required to sustain electric vehicle in the market. One first and foremost thing is a charging station. Now, it should be at shorter distance, and not only shorter distance, but also has to have the charging rate very fast. Now, there are various ways. One is that you can charge it at home overnight, but that is only useful when you want to commute from your place to workplace and come back, and a shorter distances. If you have to have the longer distance, you have to have a fast charging and at intervals. So fast charging is usually around 1.5 hours or something like that to fully charge from 20% to 95%. Then ultra fast charging. There is a particular company in Sweden which provide a charging rate at such a faster rate that, let us say, the buses which are commuting, the public transport buses which are commuting in the city, they stop at the bus stop to pick up the passenger and drop the passenger. Within that 10-15 seconds, you can very well get a charging. So this is one way, another way to do it. The third way probably is that you build a road which will have a charging lane. Now, we are going to have one of the charging lane on the road from Delhi to Jaipur highway, and later on from Jaipur to Mumbai highway, wherein if you drive in that lane, the vehicle gets charged automatically. So this is another way to look at it. Then you have, especially for two-wheelers, if you have a swapping station, like you spend spare the battery, you spend the energy out of the battery, and then go to a fuel pump like we used to go for a gasoline engine, give you a battery and take another freshly charged battery, so you don't have to wait. So that's battery swapping, we call it as. Only problem with that is who will own the battery, because it's not your battery anymore, it's in circulation. So these are some of the things, but it's very well going in Taiwan, and it's very popular out there. So these are some of the infrastructural charging issues. Along with that, we have to consider what is the charging time that is possible. As you increase the temperature, the charge retention is very low. So you have to consider all those factors while developing an electric vehicle. What is the basic layout? How do we go with that? So this, if you see the picture, you can very well see that it is more or less similar to, a fuel tank is replaced by a battery pack, and an engine is replaced by the controller and the motor. Transaxle or the speed reduction box will be only the initial one, and then the drive remains same. So basically, it is something similar to ICE, that is the internal combustion engine. Some of the parts have been replaced with the electrification of the vehicle, and as you see that, sorry, as you see, the most of the systems like cooling system, braking system, power electronics, even for that matter, are same. What additions are the small tidbits like battery charger, charging contact, whether it is a type 1 or type 2 charger. These are small elements or aggregates which gets fitted on the vehicle in place of, in case of ICE engine, you need to have a fuel inlet for filling the tank or something. Instead of that, you have a charging plug or plug-in, what we call a charging plug instead of a fuel lead. So these are the small differences that converts a conventional vehicle into EV by replacing few parts and by adding some new parts. So this is a basic layout. Rest of the mechanical systems above the chassis are same. So the body and the frame is more or less same as that of the conventional vehicle. Now, what are the peripherals? What are the things that you need to have on the vehicle to make it electrified? But before that, if you see on the right and top corner, there are three definitions. One is a micro hybrid, wherein only start-stop function, meaning when you're stopping at a signal, the vehicle gets cut off. Why this is there? That this is to improve the efficiency, fuel efficiency or mileage of a vehicle. Then the mild hybrids, wherein along with the start-stop, that is, we call it as engine start-stop, so the short form ESS. Along with the engine start-stop, we have an integrated starter generator. Meaning there is no need to have an alternator because the integrated starter generator itself will act as, and there is no need for a separate charging circuit because integrated starter charger, etc., will produce the electricity, will charge the low voltage circuit, that is 12 volt or 24 volt, to run the electrical devices such as lamps, horns, infotainment system, etc. So that is a mild hybrid. And a full hybrid is, there is an engine as well as there is a motor. So at a time, both can be operable, or sometimes only the engine is operable, sometimes only electric motor is operable, or fully electric motor is operable. So that's a full hybrid. When it has got a provision to plug in to your socket at home or at charging station, then it is called as a plug-in full hybrid. You get the differences or the nuances. Now here, if you see the if you see the gray parts, these are the ICE engine parts. So if you remove them, then the vehicle becomes electric vehicle. You put them, then it becomes a hybrid. If you remove the electric parts, then it becomes a conventional vehicle. So this is one of the diagram which I am very much into the liking, that you can very well see how it becomes or how you can convert a conventional vehicle into electric vehicle or conventional vehicle into a hybrid electric vehicle. So it all depends on this. So wherein you can have any of these functions, that is start-stop function, integrated starter generator. Mind well, even integrated starter generator can be used on a conventional vehicle. So if you have a conventional vehicle and you fit ISG, then it will also give you better fuel efficiency. So that's the way it is. And of course, when you use a fully electric vehicle, then you have almost zero pollution. But at the same time, the other problems like longevity, the reliability, thermal incidences, range, etc. matter. So this is how you can have the electric vehicle and its parts, which can be superimposed on the conventional vehicle and vice versa. Now, what are the different types of EVs? As I earlier said, that we have a hybrid electric vehicle wherein the fuel is gasoline and electric motor. So there is both things possible. Either you can have the ICE engine running or electric motor running. So that's a hybrid vehicle. Now, plug-in hybrid, as I said, that if you have a provision for plugging your battery, in this case, the battery pack has to be replaced after every discharge. So that's no one uses it, but just to give you an idea of it. Plug-in hybrid, you can charge the vehicle whenever you are having. At the same time, you can put the fuel and also run the vehicle on gas or gasoline. That is a plug-in hybrid vehicle. And then the purely battery electric vehicle. So there is no ICE or internal combustion engine involved into this. There is purely an electric vehicle which can be plugged in for charging, and it runs pure 100% on the battery power. So this is a battery electric vehicle. Once we know this, then where we are moving? Probably to the future, having fuel cell electric vehicle. Because fuel cell electric vehicle will be much less in weight, will be much more faster, will have no problem with the range. Today, yes, it is very costly and the technology also is not so easily available. But quite a few Indian OEMs, including Tata Motors, have already developed the vehicles with fuel cells and they are undergoing trials. So I don't find any problem if we see fuel cell vehicle on a commercial electric vehicle on a commercial basis, probably in the next 5 to 6 years of time. So that's the future we are talking about as per the electric vehicle. It's not just electric vehicle, but a fuel cell vehicle. Now, here, there is also one more thing, that these fuel cell electric vehicle will also become autonomous vehicle. I'm going to show you one video clip at the end of the presentation, and you will see how the things are moving. So please hold your patience. We will have that as a futuristic vehicle kind of short video on that matter. Now, we know for sure what are different types of electric vehicles, but what is it that makes a difference in the electric vehicle? The difference in the electric vehicle can be dependent on the various powertrain components, or we call it as a driveline component. So if you see what the configuration can make it differently. Now on the right hand corner, we have shown that the red line is a mechanical power drive. So in the three figures that you are going to see later, you will see a red line and a blue line, nothing to do with the transport system of Delhi or something where they are notorious for their accident rate or something like that. But this is just for the conventional thing, that the red line and the blue line. Now here we have a series hybrid, meaning what? The engine is in line with generator. The generator drives the motor through a set of batteries and inverters. So controlling battery management system is done by the BMS, we call it as, fitted on the top of the battery pack. And the supplies are inverted in case where you need to recharge the battery or something. So this is a series hybrid. Then there is a parallel hybrid, meaning what? Engine and motor are in parallel. So if your motor is shut off, the engine can be, driving the vehicle, and vice versa. If the engine is cut off, motor drives it. So this is a parallel hybrid. And using they have different benefits and different advantages and different drawbacks. So Toyota invented a hybrid of hybrid, that is series parallel hybrid. Now here what happens is that you can switch the lineage of engine and motor either from series to parallel or parallel to series or both ways. But here you need artificial intelligence. Depending on what is the torque, what is the speed that is required, they will decide how to go about choosing a configuration which is much more beneficial. Now, why artificial? What is artificial intelligence? Just to give you a thing. Now, let us say I'm driving a vehicle and I drive the vehicle the way I want and based on whatever driving number of years of experience I am having. So my decisions are purely based on my experience of driving. Now consider this, that there are millions of vehicles and millions of drivers, and they have their experience. This data is being picked up and sent through the cloud to a central database. I'm just making you to visualize what is AI and how it can be put to use. Now, if this data is available and if you are having a connected vehicle, the situation comes and the onboard computer or ECU of your vehicle sends a instant message, fraction of a second. Even a human cannot process faster than that. And with the experience of number of years of experience of millions of users, it synthesizes the data and gives you a decision, and then it is fed to your computer. In case of autonomous vehicle, it will be automatically articulated, or in case of semi-automatic, where the driver can prevail over the autonomy, a necessary preventive action will be taken and you will be prompted to do something like that. So this is what is the artificial intelligence will get into or put into use. And it will be much more useful for series parallel hybrid, because then they have n number of use cases wherein the decision can be taken based on so many vast knowledge of experience of different drivers, different conditions, different terrain, different types of vehicles, and different fuels. So this is the advantage of AI, and that can be used for making series parallel hybrid much more better. Now, you are having an electric vehicle and you are driving it. Now, there are 3-4 different operational modes when the vehicle runs. Why this is necessary? Because you should know what happens when you are having one mode and what happens. That will decide on the range that you will get. It's kind of a ready reckoner for a driver to use for good driving and getting better and better range of the signal. The first is start and accelerate. When we start and accelerate, there is a surge of current that will be given to the motor. So you will deplete the charging much more during the start or during the acceleration, same way as that of gasoline engine or ICE engine, that when you start and accelerate, you spend more fuel. In the same fashion, when you start and accelerate the vehicle, there will be a sudden jump in the current, and you will be spending more energy into start and accelerate. So then it will be decelerating or braking. Here you will not spend more energy, but if you are having a regenerative braking or a regenerative charging, then your deceleration will be producing the electricity. Not only that, it will also provide a dump load, or let us say load, to resist the motion of the vehicle. So automatically you will get inertial braking coming into picture along with the conventional braking. So obviously what happens, the load on the braking comes down. You have a better life of the brake shoes and other things. So this is another mode. The third mode is a normal driving, wherein you're moving at a leisure or at a higher speed. You're constantly driving in a cruise mode, and not much of the energy is being utilized. And the last is charging or regenerative. This is something similar to deceleration or braking, but here what happens is that when we are talking about decelerating through braking, it is different, and decelerating through the downhill or something, it will be generating much more electricity for the recharge module of the total system. Now here, all the picture, I have shared this with Shiva, this presentation. So you have those slides also. You can very well go through as to how the flow of the mode and the transmission of the current is happening in each of the mode. So that's one way to look at it. Along with this, we have different combinations. Like I told you about electric vehicle peripherals. And if you consider the FECV, that is fuel cell electric vehicle, it can also be converted into a normal drive with use of different, aggregates. For example, the table gives you, if it is a ICE engine, for full hybrid vehicle, it is there. Plug-in hybrid is there, but it is not there for full battery vehicle, that is BEV. So you won't see an engine here. Then you have range extender, that is auxiliary engine. If you want to have, you can have it. And a fuel cell where we don't have an engine, but we have a fuel cell stack. The electric motor will be present in all these types of, the red category of the vehicle is a category of the vehicle in the red test. And the vertical column shows what is the aggregate and whether it is there going to be in that particular combination. So the electric motor is there for all the types of vehicles, different in sizes, because if it is a fully optional thing, then the size could be higher for a purely battery vehicle. And for a range extender, it could be smaller. So this is how it goes. The power electronics, obviously, the moment you have electrification of vehicle, you have to have a power electronics. Not only for electrification, meaning electric vehicle as a prime source, but power electronics is also required for AC-AC converter, AC-DC converter, and DC-AC converter, as well as charging circuitry of your low voltage batteries and other things. If it is a motor, electric motor, which is partly or fully used as a prime mover, you need to have a high voltage battery. External charging, fully hybrid, we don't need, because then it can have onboard charging through regeneration. But for plug-in hybrid, electric vehicle, and range extender, you need to have external charge. Fuel cells, obviously, you don't need, because fuel cells themselves will create the the electric charge. And in the last row, you will see potential carbon dioxide reduction with the use of this. And that's why you will see that electric vehicle is 100% reduction, but as I said, it pollutes the water body and other thing, and other solid fuel issues or landfill issues. But definitely plug-in hybrid gives you 50%, extended will give you 90%. So this is how the drive combination will decide how much pollution you can reduce and what are the configuration, what are the components that are going to get fitted on that. How does a electric work? When you are having discharging, meaning vehicle is moving, the charge is flowing through anode to cathode, and then is fed to the drive system. While you are charging, the reversal of the flow happens, and you will see the discharge of the charge of the battery and discharge of the battery respectively. Now, this charge from battery pack is given to the inverter, and that inverter changes that either DC current to AC current depending on what kind of motor you are having, whether it is AC asynchronous motor or PMSM motor or SRM motor. This DC charge will be converted into AC charge and will be fed to the induction motor, which will drive the vehicle. Now, this motor could be a centralized motor with an initial one-speed reduction gearbox, or this motor can be fitted on each of the wheel, depending on what kind of vehicle you are having. Generally, for most of the vehicle in India at the moment, it is one motor driving both the wheels, or driving all the wheels through a transfer case. So this particular charge, when you press the throttle, a charge will supply to the motor, and the motor then drives the shaft, which in turns drive the wheels. So this is a basic working principle, what happens when you are having the electric vehicle. So far, so good. What are the other areas that we should look into? One is the charging adapters. Different vehicles in Europe, North America, Asia, India, China, Sri Lanka, which generally we use type 2. The type 1 is a slow charging, which can be done at home. You can have a 3.4 kilowatt charging at your home, or you can have 7.5, or you can have 11 kilowatt charging. It's like more charger of a mobile. When you are having mobile, you have a 25 or 30 watt charger, you have a 55 watt charger, you have a 60 watt charger. So the charging time comes down. Similarly, for the electric vehicle, there is a slow charging, fast charging, which uses type 1 or type 2 connectors. Then you have to have a high voltage and low voltage isolation. Remember one thing, human body can sustain up to 50-55 volt. The electric vehicle operates maybe at 72 volts or maybe at 300 volts, though the current will be varying, but that's highly detrimental for a human body. Now, if you have a leakage from HV to LV, not only it is unsafe for a human being, but it is also unsafe for the devices. So you have to make sure that these are isolated, and there is a safeguard mechanism available that anytime this kind of thing happens, the master switch will always be operated, and it will cut off the HV and LV circuitry totally. So this is inbuilt in the vehicle, and it is useful for avoiding any kind of incidences for leakage current and crossover of HV to LV. From LV to HV, if it goes, doesn't matter anything, but it's not good, but it's not so damaging or detrimental for either human being or devices as such. And during the regeneration of a braking, the electric motor runs as an alternator. So you don't have to have an alternator. You don't have to, I'm not talking about IG, that is integrated starter generator, which is a device for hybrid vehicles. This is purely electric vehicle, either two-wheeler, three-wheeler, four-wheeler, or commercial vehicle, wherein electric motor itself acts as a generator to feed in the HV battery again during regeneration or braking or deceleration or going down the hill. At the same time, the electric motor will also be used for drive when it is not acting as a generator. So you get what I'm saying. It's kind of a bigger ISG, so to say, as a prime mover. What are the major aggregators? One should know what the electric vehicle comprises of. One is a battery management system. As I said, it's fitted on the battery and is being controlling the battery discharges, etc. Thermistor module for temperature controls and other thing. The DC converter is always or contactor is always for converting DC circuitry, DC current, DC to AC or AC to AC or AC to DC, depending on which side you are operating on. If you're charging, then you need to convert DC into AC into DC. Then there are certain current sensors, brake sensors which are required. HV battery.
Excuse me, Mr. Rasula.
HV battery pack. Yeah.
No, sorry. I asked the person to me.
Okay. Then we have a vacuum sensor. Now, if you see, most of these parts are being imported from Europe or America at the moment. But for a battery pack, it is mainly from China, Malaysia, Thailand, because of their cost. And the instrument cluster obviously is indigenized based on our features and other things, so no need to go for any import on this. Current sensors and brake sensor are now being made in India locally, indigenously, DC contactor. But thermistor module, AC DC converter, on this page you will see. Motor with control, these are all mostly imported by almost all of the OEM worldwide. Let me tell you that. Even companies like GM, Mercedes, etc., are also importing it from the aggregate supplier, either in Europe itself or quite a few times in from China also. So these are few of the aggregates that you will need. Having said that, there are certain things that a designer or a architecture of electric vehicle must take the cognizance of. One, DC-DC converter is converting high voltage of battery to low voltage, but there you should make sure that there is no crossover of HV to LV side. There should not be any EMI, that is electromagnetic interference on the power electronics board. So this has to be taken into. The charging contacts must be there, so that, and with the provision that you can isolate them at any point of time, because this is the contact which is used for charging at either home or station and then fed back to the battery. The high voltage system, as I earlier said, has to be separated from LV circuit except DC-DC converter. That is the intermediate device which will allow HV to be brought down to LV, and which is orange in color, easy to see, and you will see that you can very well identify this is the power circuitry and one should not touch it, which is again because of its susceptibility for the shocks and other thing, is reinforced cable, doubly insulated, and the connectors can be used to switch the polarity. So positive can become negative, and we are very well protected from accidental touch. Then we have other voltage device, other high voltage devices, drive motor, HVAC system, etc. They have to have a warning level. You will see many warning levels in electric vehicle because of the potency of the voltage across the point. Now, as you can see, the pure or full battery vehicle do not require any multiple speed transmission because the motor is kind of a stepper motor and can provide a constant torque at all speeds, and you don't need. But that motor, if you use it, then you need a bigger motor. While as if you use a smaller motor with first one single reduction gearbox, then it gives you much more room to play with the various power curves of operation of the vehicle. So usually a single reduction gearbox is fitted before the motor and can be used for transmission of the vehicle. Braking system, mainly you have to look for regenerative braking, as it gives you a better efficiency, also charges the vehicle, also reduces the wear, and will provide shorter braking distance because the inertial braking also happens out of the charging circuitry or the inertia of the charger or motor. So this is how you should look for it. Now, some of the enablers we are looking for is that why electric vehicles are getting developed. No, first and foremost, no pollution. Second is that no emission. Maintenance and lower cost, running costs are low. Plus, you don't need, you need less mechanical parts. So less maintenance, less cost, less weight. But again, it is offset by the battery weight. You can charge the vehicle wherever, at home, at station, on the go, those kind of infrastructure are being made available. So these are the few enablers. At the same time, there are challenges, a roadblock. We have limited range. At least, okay, now people are working on it, and very soon you will see a Tata Motor vehicle with 1,000-kilometer range. So that's a different story altogether. But so far, range is limited. Typically, anywhere from 200 to 300 kilometers is the average quite reachable range for the moment for passenger cars. Poor infrastructure, charging infrastructure at the time, both from the interval or let's say the location point of view, also from the time required for charging point of view. The cost is very high. 50% of the vehicle cost goes into only motor and the battery pack. And the battery is hardly 5 to 8 years of life. So when you want to change, there is no possibility you have to replace the battery. There is another way to look at it, that this battery can be handed down to a lower grade of lower powered vehicle, and it still runs for another 2-3 years. So that those are the things which are being tried out as a business model by lot many people. Then there are limited users because of the fear psychology of having thermal incidences. There is still fear that mental preparedness is not there, and it's very difficult to storage large capacities for batteries. And as I said, the emission is also a problem as far as the water pollution is concerned. So either you have to have substitute for lithium ion, plus you have to have electricity production or generation by way of non-conventional or reusable fuels or something like that, like use wind or solar energy. We did make prototype for solar car without a battery. I mean, solar electric car, but without a battery. So these are few of the challenges that one has to overcome. Now, as I said before, we conclude, I think it will be interesting to see this particular clip as to where we are going in. Let me know if the noise is there. You are able to hear?
No, sir, sorry, we can't hear any sound yet.
Okay, this is a standard car which gets converted into autonomous vehicle. You are going from one point to another, and you want food, so just order it because it is connected. And by the time you reach that place, the food is ready. So you don't have to wait for that. So normally you save time on that. Now, once you are traveling higher and you are tired of driving, it can convert into self-driving or autonomous vehicle. While it is driving and taking you from point A to point B, you can also enjoy the entertainment on the screen, whether in the form of movie or any music or something. At the same time, you can relax with the kind of features that the vehicle provides. So that's the future. I think I'll stop here. Thank you very much for your patience. Any question and answer, I'm ready to.
Right. Thank you very much, sir. So attendees, please, we seem to have some problem with the chat box.
Okay.
Certain attendees have sent messages saying they cannot see the chat box. So
Okay.
in that case, you're welcome to raise your hand, and I will call any raised hands.
Okay, no issue.
I'm sorry, I think I saw a hand raised. Yes, Engineer Dasun Sewand, yes, you're welcome to ask the question.
Yeah. Hi. Good evening, Mr. Mahesh.
Good evening. Good evening.
Two questions. So we have several categories of vehicles which are being used for domestic purposes, and on some are used for transportation, and some are used for off-road racing, etc. And how do we address these type of vehicle categories when it comes to electric vehicles? And the second question is, what is the life time of the battery pack for each of these categories?
Okay. See, the life of the battery pack usually depends on the duty cycle. Like, for example, if you talk about a car and if it's being used by a customer like me or you or anyone for daily commission to your workplace, maybe a leisure travel on the weekend or something, then you drive the vehicle more or less about 15,000 kilometers a year. While as you take the same car being used as a taxi, then within 1 year he covers about 65,000 kilometers. So depending on the usage, the battery life will change. Now the question is how much life you get for the passenger car. If you are talking about the first category, you and me, then easily 8 years is one of the life that I would say. The same car being used as a taxi probably you'll get 5 years. So that's a ballpark figure for life of the battery stack as such. Now for commercial vehicle, it is further less. It will be 3 to 5 years only, because the loads, the duty cycle, and the number of kilometers that are driven per day will be much more higher than the passenger car. So for any commercial vehicle, the battery life could be between 3 to 5 years, depending on what type of vehicle, whether it's a light commercial vehicle, a small commercial vehicle, or a medium commercial vehicle, or a heavy commercial vehicle. It is same as that of gasoline engine. You have the car average of 10 to 15 kilometers per liter. You get an average of 1.5 to 2 kilometers for a truck. So it's something like that. So battery life usually changes from 3 to 8 kilometers over all these categories, depending on the duty cycle, the usage pattern, and the type of the vehicle. Does it answer your question?
Yes, sir. Thank you.
Okay. Okay.
Thank you, sir. We have another question from, I think, Mr. Tarana Vasala. You're welcome to raise the question.
Yes, sir. First of all, thank you very much for the very informative lecture. I think it was very useful. And my question is regarding the components that you were talking about. You were mentioning that there are many components that even the manufacturers import from other manufacturers and so on, like, cross production of components for electric vehicles, and
Yeah.
different countries which are able to produce different components due to their availability of raw materials and so on. So my question is, in your opinion, what are the components that are in a higher demand for external importing? Like, what are the components that manufacturers prefer to import from other countries, and what are the components that, like, for a start, if a manufacturer wants to, like a small manufacturer wants to start production, what are the components that are easy to start manufacturing?
Yeah. Good question. Before I answer your question, let me tell you something. See, any aggregate component which are being imported is not a question of whether it is imported or indigenous first in the first place. Whether that component is being made in-house or bought out, this is the decision a company makes in the upfront, because making all component in-house is also not a good business case, because you need a lot of investment. Your overheads are higher. It's something like that, you get a tea at Galadhari, probably 100 rupees, and the same tea or better tea you will see on the Colombo beach for 5 or 10 rupees, isn't it? So this is because the overheads are. So there is a decision making happening before the development, that whether this component is to be bought out or this is to be made in-house. If it is made in-house, then you have to have all investment already done for other areas. Like mechanical components will be made in-house, because anyway we are making it for ICE, that is internal combustion engine. The transmission item mostly will be made in-house by any OEM. The engines probably will be made in-house, but the aggregates like this, for example, ECU, whether it is for the regular conventional vehicle or whether it is for EV, will be bought out. Now, such is the decision based on the cost and the return on investment, balance. We will decide whether a particular component is to be bought from outside. Those are called proprietary parts. Now, these proprietary parts now have to be decided whether it is to be imported or made in-house. Now, generally, these decisions are governed by whether the technology is available with the Indian counterpart. Obviously, we will prefer it from our Indian counterpart, because then it becomes less costly, less cost. Also, the logistics is better, and then the reliance on outside and the factors associated with becomes less. So we will try to prefer the indigenous supplier. Now, if any of these components are not available, then we have to import it. And such are whatever component I showed are mostly the bought out components. As I said earlier, some of the components like wiring harnesses, the sensors, the DC connectors, etc., are bought out, but are from Indian supplier, tier 1 suppliers. For all controllers, the drive motor and its controller, the battery pack, the DC and DC AC converters are imported. Usually, the battery and the battery pack is being imported from China or South Asian countries, and the controllers and the AC-DC or DC-AC converters and the power modules are being imported from Europe, typically Sweden, Germany, and some part in Mexico. This is how the distribution of components. So first and foremost is that whether you have to decide whether it is to be made in-house or to be bought out as a proprietary part. And only proprietary part to be bought out have to be decided about whether they have to be imported or they have to be purchased from Indian supplier. Now, the maturity of Indian supplier, the reliability of the component, the durability of the component from an Indian supplier will also be considered when we consider cost, with the other supplier, because we can't shortchange the customer. So unless and until we have a fully reliable indigenous product, we won't go in for buying from the indigenous one. When I say indigenous, it's any country. So if that country is good enough technology for reliability and durability of that particular component, then it is bought out as proprietary product from within the country. If not, then it is imported. And today, if you see, I would say most of the OEMs in India or any Asian country are buying, the batteries and battery packs, and in some cases, some of the wiring harnesses from China. Battery management systems in China, but the algorithm and logic is defined with either in-house capability of algorithm development or Indian supplier algorithm or European. But that's very rare. However, to repeat, the battery pack, the battery management system, and some of the HV cables are being imported from China. The power control board, the AC-DC converters or DC-AC converters, the motor and the motor controller is being imported mostly by us and most of the OEMs in India through Europe. And in Europe, meaning Sweden, Germany, etc. This is the whole picture. So if you consider there are about total 60 to 70,000 parts which are required to be decided for in-house manufacturing or proprietary buying. And let's say out of 40, 60,000, there are 10,000 parts which are proprietary buying. Out of 10,000, probably 8 to 9,000 will be indigenous built. Remaining 1,000, you have to consider whether to import, and if import, from where. This is the whole procurement cycle that happened. I told you about the components and the countries. Do you need anything more on that? Hello?
Yeah, thank you, sir. I think that was a good explanation. Thank you very much.
Okay. Okay. Thank you. But a good question.
Thank you.
Yes, please.
Yes, thank you very much for the question. We have some more questions, and we are also running.
Yeah, no problem. As long as you guys are okay. No, as long as you guys are okay, I'm okay. I'm open for all, and don't worry about it.
Okay, sir. I'll ask them in the order in which they raise the hand. First to Mr. Vishwanath.
Yeah.
Thank you. Good evening, sir. Please. Hello, can you hear me?
Yeah, I'm able to hear you. Go on.
Thank you. Good evening, sir.
Good evening.
First of all, thank you very much for your informative presentation, and we learned a lot of things. Thank you.
I'm happy for that.
So, your presentation, you talk about two types of brakes, engine brake and the hydraulic or mechanical brake.
Yes.
So my question for an engine brake, sir, for engine brakes, considering about different categories, whether it is two-wheelers or three-wheelers or quadro, are there any for this engine brake, which means it defined that values should maintain in each category of whatever, are there any standard? So that is my first question. And the second one is,
no, I'm sorry, I lost some of the words. Can you repeat the question? I got everything what you said, but the question itself was a little inaudible. So can you repeat the question?
Actually, during your presentation, so you talk about two types of brakes, engine brake and the hydraulic or mechanical brake. So
correct.
My question is, for engine brake, if we consider different vehicle categories, suppose two-wheelers, three-wheelers, and the quadro, are there any added engine brake value or benchmark should maintain for each category, or what is the level of standard for this engine brake?
Okay. Okay, I got the question. So
First
should I
question,
answer that, or you want to ask the second question also?
I'll ask the second question. So the
Okay.
second one is for testing and evaluation in EVs, what are the mechanical standards, especially for the powertrain?
Okay.
So I expect that answer for each category is actually two-wheelers, three-wheelers, and quadro. So if you can provide that, there is
Okay.
beginning.
Okay. Okay. I'll answer it, but if I have to give you the answer here and now only, probably will end up till tomorrow morning or something like that. But anyway, I'll answer suitably. Now to your first question, there is no difference as engine brake. When I say engine brake, it is not a separate entity. Engine brake is by virtue of moment of inertia of an engine which starts resisting the vehicle motion. That is called as an engine brake. Whether the engine is of ICE or whether it is an electric vehicle, the inertia of the vehicle when put into a regenerative mode gives a reversal of the resistance to the vehicle motion. So that is the engine brake. So depending on the vehicle weight and the capacity of the engine, whether electric motor or whether it is ICE engine, it will give subsequent resistance to the braking of the vehicle by way of, supposing you are running, okay, and suddenly when you say running, let's say you are skateboarding, and then you put your foot down, and you have a friction with one foot to the ground. So that is a mechanical braking, let us say. At the same time, supposing I blow air from the front, then your motion is always given a resistance, so that becomes a engine braking. So your running is opposed by the inertia of the environment. In case of your running, in case of an engine, the engine itself creates a back pressure on the moment or the rotation of the wheels, which is called as a engine braking. So it's not a separate device. Am I giving you a little better thing? Are you getting it? Okay.
Yes.
This is one. Now to your second question. There are various norms. Usually for testing and validation, each of the company, along with the standards which are available, they also have their own standards. Like for example, I handled testing and validation for almost 10-12 years, and we formed our own test standards. So those are called TS or Tata specification, which are exclusively used by our own vehicles. Over and above, each of the company will have some standards. Like we have taken reference from Jaguar Land Rover, we have taken reference from Ford and GM and modified our standards. So this is one way to look at it. So there are about 10 to 12,000 standards we made for ourselves. In addition to that, there are SAE standards. In addition to that, there are ARI standards. Why ARI standard? There is a CMV, Central Motor Vehicle Rule, and they have various standards like AIS 119 or 104 or AS 153. These are the standards which will be used for specific aggregate. I was talking about the noise pollution. The pass-by noise standard is something different. So in pass-by noise, supposing you have to measure a vehicle passing through a center point wherein you have your mic at 1.2 meter above the ground, and 10 meters before that point, the vehicle should accelerate, keep on accelerating 10 meters beyond that point, and whatever is the maximum noise that is created, which will be captured as your pass-by noise. So this is a state specification put by ARI, and you have to test it accordingly. So for each of the component, each of the function, there are various standards, and at least they'll, okay, let me tell you one thing. For any vehicle program, since I was looking the whole vehicle, whether it's an electronic component, mechanical component, electronics component, or CE or structural component, for any vehicle program, I had to do 96,000 more plus test. And for each of these tests, there are standards. Now you get my dilemma as to whether if I start discussing those 96,000 test standards, it will be difficult, isn't it? So there is no specific, but to start with, I'll tell you something. There is a CMVR rulebook, and it gives all standards list what it should follow as a standard company, SAE standards or CMVR standard. Over and above that, each of the OEM will have their own way of test specification. Why? Because typically in that country, you may have different conditions. For example, now European guys test their music system for a 1G or 1.5 at the most G level of road inputs to the wheels. Meaning there is a 1.5 or 1G acceleration coming on the vehicle, and in that vibration, your music system should last long. Now, if I have to test it for here, my roads are so bad, unfortunately, that I experience 2.5 to 3G. So I make sure that my system is more than withstanding more than 2.5G. So this is my own standard over and above a regular European standard for the test. Now, if you want to go in for that, there are ECE, E for Echo, C for Charlie, E for Echo, ECE standards. And there are ECs, that is European country standards, which are applicable more or less throughout the world. In addition to that, there are CMVR typically for India. In addition to that, there are GSE standards for Middle East countries. In addition to that, there are South African standards for South Africa, because the temperatures there are much more lower. Typically, if I check the starting system for minus 10 degrees centigrade, which will be a temperature in Kashmir, probably I may need to go to minus 30 for South Africa and minus 40 for Ukraine. So these are the specific things that are applicable to from country to country, and you will have more and more additions of that. I'm sorry, but these are the number of test standards which I have given you: CMVR, EC, and EC standard. If you start going in for that, then you will get all the details of specific standards for the aggregates.
Okay, so thank you very much.
Yeah, thank you. Thank you, sir. We seem to have a small problem with the time, so because of that, we can I'll allow another 2 more questions. Any more?
Okay.
If there are any more questions, can they reach you through email? Is that an option?
Sure. No problem.
Okay, the email address shown on the slide, the Gmail, the Mahesh Shinde Gmail. Is there anyone you prefer? Or
yeah, I'll prefer that personal maheshshinde@gmail.com. The sage.ecs9 is my consultancy service mail address. But with the personal thing, I'll be able to reply much more faster. So you can use anyone, but I would say that you can use personal one.
Sure, sir. So for clarification, please use the second email address, maheshshinde@gmail.com, to reach is Mahesh Shinde for any further questions.
No. Not Mahesh Shinde. It is one SH has been cut. So Mahesh Shinde. Mahesh ends with SH and Shinde starts with SH.
Yes.
So one SH has been cut. So it will go to some other. There is a mail ID of Mahesh Shinde also. So please make sure that you use this one. Don't say Mahesh Shinde, because it will go to somebody else and you will start cursing me that I'm not replying.
Sure. Understood.
Okay.
So I can take 2 more questions in the order in which they were raised. One is from Engineer Dr. Devasurendra and the other is from Dr. Kumar Jayavikrama. I'll first take, if Dr. Devasurendra...
Yeah. Can you hear me, please?
Yeah.
Yes.
Yeah, okay. Now this is about this supply chain, for these large scale components, the big builders of these components, right? Now, for instance, if there is a dispute, for instance, you enter into an agreement with one of these suppliers for a period of time, and then they kind of breach the contract. For instance, I have installed equipment here to assemble cars, and for whatever reason, political reasons or whatever, sometimes some countries can use this as an arm twisting exercise. Right now, how does it happen because this is international kind of inter-country, right?
Yeah.
Is there any kind of means of dispute resolution? That's the first question, right? Second question is about, well, of course, I want to ask this question about standards. I think you gave a very nice explanation, right? Now, about the reliability and who liability, for instance, for these components. Now, the using of these components and where does the liability lie, product liability lie?
Okay.
I mean, is there legislation for this kind of thing? Because, right, so because I'm asking you because you are already using this now in your companies, right?
Yes.
So what do you do? And the third, last one is, what's the level of indigenous kind of technology or the capability development that you do in India, for instance, because you can't have long-term dependence now. But then you can even think of, I'll give you an example, re-engineering, how much of re-engineering is or reverse engineering is permitted. So the moment you start doing reverse engineering, you will be blacklisted by the supplier, right? Because they won't like it, right? But I'll give an example. A long time back when I was in France, I was told by people there, because I was doing my PhD there, somebody who came from one of these big companies, they said they buy any car which is put out by any company and they, you see, they basically re-engineer. I mean, reverse engineer, right? They do it and nobody has access into these laboratories and so on. This was in 1966, 86. I was told, right? They have been doing it. So what are the possibilities? How does it happen? Because nobody wants to be completely dependent on anybody else for geopolitical reasons, for all kinds of reasons, right?
Yeah.
All right. Yeah. Because, okay. Thank you. Right. That's it.
Okay. So I'll answer your questions one by one. First of all, you're talking about litigation and how to protect yourself for what is the jurisdiction and all those things. Now, usually what happens, I'll tell you. When you give an order for components or something, your purchase order clearly talks about, or should clearly talk about, in case of dispute, what will be the judicial area or authority which will be dispute will be settled. So that is binding internationally. Once it is put in into the purchase order, it is binding, and then the but that particular judicial authority will, be capable of giving you a justice or something. So it has to come to that level. Now, let us assume that the company which you are getting the components from goes bankrupt, or they are not in a position to give you the components to the necessary quantity or quality or something. There is another clause called as a bank guarantee. Now, this bank guarantee, usually if you want to protect it, you can very well ask the supplier to give you a bank guarantee for supply of that. In case it fails, then his bank guarantees you to pay certain money back. The third part of it will be, even if you don't have bank guarantee, you can have the insurance. So that is the third way to look at it. So one is spelling out the judiciary in case of dispute within your purchase order, getting a bank guarantee within your purchase order, or putting an insurance to the scale. Typically for us, startups and all those which collapse, this happens. Even if everything fails, then there is another way to look at it. And that sort of, answers your third question of re-engineering, which I'll come to shortly. But yes, you can very well find out in the market. Like it's like, the OEM supplier for the original equipment manufacturer brings or buys the material from a certain supplier, and that company supplies you, and that company is now not in a condition. But remember one thing, there is always an aftermarket. That aftermarket, there are very few number of suppliers which are replicating by way of re-engineering these components are available at a cheaper rate. You may have a little bit of problem for the reliability, but at least your work will not get stopped. Something like that. This is a prescriptive, action that you can take. So this is a full answer for your question number one. Question number two was regarding the test procedures and all those things, which I said that this is vast subject, and you can very well find out these particular test standards from OEM to OEM, from country to country, and all of it. But you wanted to know something else about that. What was it?
No, the other thing that I wanted to know was, well, the third question, in fact, was if you started to do,
No,
if you wanted to do
I remember.
reverse engineering, right?
Yeah. I'm coming to that. Right? Yeah, I'm coming to that. The third question, yes. Now, let me tell you one thing. Every company, meaning every company in the world is doing reverse engineering. The question is how good you are at it, number one, and how good you are able to produce any component aggregate system slightly or majorly different than what you have reverse engineering, so that you don't end up into litigation of intellectual property rights. This is one thing. Now, I'll give you a classic example. You have heard of Bajaj Auto?
Yes.
Okay. Bajaj Auto had a very high selling model called as Pulsar, a motorcycle. Okay.
Yes.
Typically in China, they are very good and very fast at reverse engineering. So they reverse engineering this Pulsar and made a vehicle. And they named that vehicle as Dilsar. So PULSAR, Pulsar was the name, and Chinese people put their name on their model, reverse engineering model, as Dilsar. So Bajaj Auto went into litigation. So even though they were little clever on making subtle changes so that you cannot break into that, the overall impact of Pulsar to Dilsar and the same looking model and all those things, the international court did ask Chinese to change their name, not the vehicle, because they were clever enough to change the technology or little changes. But on a morality ground, the court did tell Chinese guys to change the name. So this comes as how good. That's why I'm saying how good at it. Otherwise, everyone reverse engineers the whole thing. Number one.
Yeah.
Now, even if you reverse engineering, you should know what exactly is the critical to quality parameter into that. That you should be able to identify. Otherwise, the reverse engineering is nothing but a measurement. It happens only measurement. No, that's not a reverse engineering. Reverse engineering is to know the philosophy, the technology, and the dimensions.
And the material. And the material.
Yeah, and the material. And the material. The material is very easy to find out. Very easy to find out.
Not easy. Steel, for instance, there are all kinds of steels, all kinds of cast irons, all kinds of aluminiums.
No. Yes. Right. No, okay. If you want to know any kind of material, ask me. I'll be able to do it for you. So, material. The problem with the material identification is only with the plastic, which are thermoplastic, which changes their signature, and during the molding. And then it is little difficult for the copolymers and the plastics, which are thermoplastics. So it depends. Otherwise, metals, no issue at all. But anyway, that's not the point of discussion here. The thing is that, yes, reverse engineering is being done and being used as long as you don't breach into the litigation by way of exact copying or something like that. But otherwise, the technology or the principle is definitely re-engineered into a different form.
Thank you.
But that is the way currently it is happening, because most of the things which we see are the culmination of the trends in the market and how the things are going in, and people try to replicate those features from the usage point of view, but not from the looks point of view. Look point of view, you change it. So that is the way we talk about reverse engineering. But at the same time, as you rightly said, there are certain technology that we need to develop in-house or within India or indigenously within the country. Why? Because your business is threatened by the competition, or your business is being shortchanged by the suppliers. As you rightly said in your first question, that is not the supply, then you need to develop it
because you have regional collaborations. For instance, European Union will always prefer to supply European manufacturers, right?
The classic example was the semiconductor chips. In COVID days, semiconductor chips were not available because most of the chips went into gaming business because people were at home and they were buying gaming consoles more, and those guys were paying much more, and the automotive industry did not get semiconductor. So it forces you to invest into semiconductor. Likewise, Tata Motors has plans to develop semiconductors or alternates. We have plans to develop our own fuel cells. We have plans to develop. This is how it forces you to indigenize motors.
Thank you so much. Thank you so much.
Yes.
I think that's extremely illuminating. Yeah. Okay.
Yeah.
Sorry. Thanks. Sorry.
Okay.
Yes,
Thank you.
sorry, I think we have to move on to the last question.
Yeah.
Yes, the last question is from Dr. Kumar Jayavikrama from University of Ruhuna.
Okay.
Okay. Thanks very much, Mr. Mahesh, and it was a very insightful presentation.
My pleasure. My pleasure.
Joining and in fact, like we are working on this hydrogen-based vehicles and fuel cells and all that. You just mentioned about fuel cell vehicle as well, and could you get little elaborate? Because I know that India also there are different parts are developing like on fuel cell vehicles. Could you first elaborate a little on this,
Sure.
the conversion of electric vehicle to a fuel cell or hydrogen-based vehicle and the roadmap of developing such, vehicle stream of India?
Yeah. So for first, I'll start with the hydrogen vehicle. Now, the hydrogen vehicle which are being developed are basically semi-hydrogen vehicle. Why I call this is my term? I mean, it's not an industry term. Why? Because the hydrogen is being injected into ice. The current trend clearly shows that no one wants to go into a full hydrogen because the storage capacity of the vehicle will be limited, and it will also create a weight problem. It will also create a space problem. So people in India are thinking of having a semi-hydrogen vehicle, meaning injecting hydrogen into ICE engine, thereby reduce the emission. At the same time, you don't, I mean, it's like a hybrid, like hybrid electric vehicle is a hybrid hydrogen vehicle, wherein you use the advantage of the hydrogen to reduce the emission. Yet, being semi, you don't need a bigger tank or something like that on board of the vehicle, unless you have a hydrogen generation on board. Even if you have, and that's very much possible. IIT Mumbai students have created a model where, with the help of metal oxide powders and water, they were able to produce hydrogen. But the problem is that when you have this plant on board of the vehicle, what are you going to do about the sludge formation out of that when water gets mixed with the hydrogen, metal hydroxides? The slurry or precipitation has to be disposed of. And during every, like a steam engine, you have to take away the burned coal or burnt wood every few kilometers or something like that. Who is going to take out? So there are certain issues with onboard generation of hydrogen, but definitely canister, high pressure canister, again, which is associated with the safety of it, has forced Indian industries or Indian vehicle sectors into thinking of hydrogen injected ICE engine at the moment. And I'm sure as an engineer, I would say, not as an employee of Tata Motors, but as an engineer, I would say, I don't see much of the progress with hydrogen powered vehicle as of now, unless we leapfrog into the fuel cells, which is very much on the cards. So the fuel cell vehicle, again, is related to having the technology available here. And that technology is available. How to accommodate, institutionalize, and take advantage of it is in our hand. So there are quite a few things which have happened. For Tata Motors, we have already made a fleet of buses on fuel cell. We have already made a fleet of buses on hydrogen. Some of them are running in Spain for testing. And our counterpart, Ashok Leyland, has also made fuel cell and hydrogen injected vehicles. So these are the only two major OEMs, and of course Mahindra in passenger car with their collaboration with someone are trying, but they are, let's say, 1 or 2 years behind Tata Motors and Ashok Leyland in terms of fuel cell technology as well as in terms of hydrogen technology. Other than that, there are certain local things happening in IIT Madras and IIT Mumbai, plus some of the startups which are thinking of making a fuel cell vehicle as such. So this is a scenario in India. I would say the technology for both hydrogen and fuel cell, not so much in nascent stage, but it's in the early days of development. And slowly it will take about 2 to 3 years to further get a maturity on those.
Yeah, thank you, Mahesh, because because a lot of booming things are happening here and there. So that's why I just want to know. Thanks a lot for sharing the.
Most welcome. Most welcome.
Okay, thanks.
Okay, then thank you very much, sir. Then I think if anyone has any more questions, you can contact Mr. Mahesh through his Gmail account. Then we've come to the end of this evening's proceedings. I would like to invite Mr. Lasantha Kurugula-Arachchi, the chair of the Sri Lanka group of the IMECI, to deliver the vote of thanks.
Good evening, everyone. Hi, Mahesh.
Good evening. Good evening. Good to see you.
Yeah, Mahesh, thank you very much for your wonderful presentation. Actually, we enjoy a lot. We learn a lot from your presentation.
No, I'm happy if it is useful for all of us, because usually if you share the knowledge, it also increases your knowledge. So it's always my pleasure to be associated.
Okay. And also, we know in this virtual platform, it's very difficult to handle this kind of highly technical presentation, but you manage very well. Thank you. Thank you for your time and effort. And also, I would like to thank you for all attendees. I think today head count is fairly good. We had more than 70 odd attendees for this presentation. Thank you for all. And also, I would like to thank you, especially I would like to thank you to who's Dasu, organizer of this presentation. He has organized this very well. And also, I would like to say thank you to Dr. Jaya Gamage and Lakindu De Silva, our moderator. And also, I would like to thank all IMECI Sri Lanka group members for your presentation for this lecture. And also, I have a very special announcement for you. Chanaka has been appointed as the vice chair by trustee board. I think it's a
very good news. Yeah. Okay, very good. My congratulations to him and as well as a whole Sri Lankan IMECI community. I'll talk to him.
It is the highest position which international member can achieve. And anyhow, Chanaka got that position. So I would like to say, I would like to congratulate to Chanaka.
Yes.
His effort to his journey for this position. And also, I would like to say thank you again, Mahesh. So we will meet soon.
Sure.
And, thank you, everyone. Thank you so much.
So thank you everyone for your patience and consideration. So any kind of question or support or help I can be able to give, you're most welcome to touch base with me. Thank you so much. Thank you, everyone. Shall I sign off?
Yes, sir. You can sign off. Thank you, everyone, for joining. Good night.
Thank you, everyone. Sure. Thank you, everyone.
Good night.
Bye-bye. Good day. Good night.